We would like to look at an interesting problem in partitions, an early problem that actually was the one that motivated Euler to come up with the theory of Q-series. So to explain the problem, let's consider the partitions of the number 5. So we have the following partitions, all ones. Then we have 3 ones and the number 2, 1 and 2 twos, and then 1, 1 plus 3. Then we have 2 plus 3. Oops, let's not forget 1 plus 4. 2 plus 3. And finally, we have 5. So this means that altogether, 5 has 7 partitions. Okay, now let's single out the partitions whose components are odd numbers, just odd numbers. Let's denote them with a blue check mark. So we have this one, then we have this one, and finally we have this one. The other 4 partitions have at least an even number in them. And now let's consider the partitions that have whose components are distinct numbers. So partitions that have no repetitions of numbers. So which ones do we have? We have 1 plus 4, 2 plus 3, and 5. Okay, so if we denote by P sub O, O standing here for odd, sorry about this. So if we denote by P sub O of 5, the number of partitions into odd components, then we found 3 of them. And if we denote by P sub D, the number of partitions into distinct components, sorry about this again, some problems with the iPad. So if we denote the partitions into distinct components by P sub D of 5, then we have again 3 of them. It would be a fun little thing to do this for 6, for 7, and find the partitions into odd components and then find the partitions into distinct components. And you're going to see that every single time you got the same amount. And that's what people noticed. And it's actually quite remarkable, the kind of things that people notice when they look at an object like this, for example, partitions in this case. So they came up with a bold conjecture that this is the case every single time, but they couldn't prove it. And they asked Euler for his assistance, and Euler pretty much proved it in a brilliant way that introduced mathematicians and mathematics to the Q-series for the first time. So the problem that we're facing here is that, let's write it down, to prove that the amount of partitions of a number into odd components is the same as the number of partitions into distinct components. So we will see how the theory of Q-series enabled Euler to actually prove this. And that's it. Thanks for watching.